Physics, Part 402, the piezoelectric transducer. A transducer is any device that converts energy from one form into another. Piezoelectric crystals, such as quartz, have a complex ionic structure. In the normal unstressed state of the crystal, the center of the charge of the positive ions coincides with the center of the charge of the negative ions. However, when pressure is applied to the crystal changes shape by a small amount, and the centers of the positive and negative charges no longer coincide. A voltage is generated across the crystal. This is known as piezoelectric effect. The magnitude of the voltage that is generated depends on the magnitude of the pressure on the crystal, and its polarity depends on whether the crystal is compressed or expanded. That is, whether the pressure applied is greater or less than the ambient pressure. A sound wave consists of a series of compressions and rarefactions. If a sound across the crystal that varies in a similar way to the variation in pressure of the sound wave, to detect the voltages, opposite faces of the crystals are coated with a metal and electrical connections are made to these metal films. Since the voltages generated are small, they are amplified. The crystal and its amplifier may be used as a simple microphone for converting sound signals into electrical signals. The symbol for a microphone is shown in the figure. The metal wire strain gauge. In engineering, it is frequently necessary to test for the strains experienced in different parts of the structures. This can be achieved using a metal wire strain gauge. A strain gauge consists of a length of a very fine metal wire sealed into a small rectangle of thin plastic as shown in the figure. In use, the strain gauge is attached firmly to the structure to be monitored. When the plastic is stretched, the fine wire will also be stretched. The wire is strained, causing its length to increase, its cross-sectional area to decrease. An increase in length and a decrease in cross-sectional area both result in an increase in the electrical resistance of the wire. The resistance R of a uniform wire is related to its length L, the area of cross-section A by the expression R is equal to PL over E, where P is the resistivity of the material of the wire. If the wire increases in length by only a small amount, delta L, then the change in the cross-sectional area may be assumed to be negligible. The new resistance of the wire is given by R plus delta R is equal to P into L plus delta L divided by A. By subtracting these two expressions, the change in the resistance delta R is given by delta R is equal to P delta L divided by A. Since it is assumed that A is constant and P is also a constant, then delta R equals delta L. Since the strain is proportional to the extension delta L, then the strain is also proportional to the change in resistance. We've got few examples for you. Explain what is meant by a negative temperature coefficient, thermistor. It is an electrical device whose resistance decreases as its temperature rises. Example number 2. Suggest why the resistance of a strain gauge changes when the object onto which it is fixed is strained. The strain gauge consists of a grid of fine metal wire in a plastic envelope. When the envelope is stretched,